Welcome to a Dyson Sphere Program tutorial. My name is Nilaus, and today we're going to look at how and why energy exchangers are absolutely awesome. Yes, you heard it here first. They're awesome, and accumulators are awesome as well. So, yeah, don't listen to people who say they suck and they don't work. They are just, well, they're a bit difficult. They're like kids. You love them, but they're a bit difficult at times. So let's manage the hell out of these energy exchangers and see if I can persuade you that they're actually quite awesome. So I'm going to be doing three things in this tutorial. I'm going to be doing the first section. I will be explaining how they work, so that if you kind of looked at the accumulators and the exchanges and didn't really know how they were supposed to work and just left them on the wayside and went with other inferior energy transfer method, then you will get a good benefit from this one. The second part, I will be talking about how to manage energy accumulators on a galactic scale, so you never get into a jamming situation. And thirdly, we're going to show a self-balancing exchanger setup. So the two sort of major points here may not make a lot of sense, but we'll get through to them and highlight it when we as we go through the first section. Let's start from the beginning. Well, that's a great place to start, isn't it? Let's take a look at the energy exchanger. So the energy exchanger is a weird and super interesting concept. I absolutely love it. I wish it would be just refined a tiny bit so we don't have to jump through so many hoops to make them as awesome as they truly are. But the idea is that they will take, they have two modes. Well, technically they have three. They have an idle mode, but they really have a charge and a discharge mode. In the discharge mode, they take full accumulators and they take the charge out of the battery and give it into the network, leaving an empty accumulator. So it goes in here, and then it discharges, and it goes out there. Or they have a charge mode in which they... Let me just see how I'm going to be building one of these charge modes here. Whoop, there we go. Oh no, that's not what I wanted. I'll build one of these. There. Seems like a good way. We'll set it to a charge mode. So that means it'll take power from the network and put it back in here. So you can see this is also the maximum rate. Maximum rate is 45 megawatts per second. Now in this case, you can say it's a bit silly that I'm both discharging and charging at the same time, but that is a feature that you can do. So that's the very core of it. They do take charge accumulators. So the interesting thing about accumulators, there are buildings that make a weird hum. Weird. And I'll take one of these, a few of these. So you can also set these. They will charge and discharge based on the network, but I would recommend not using them, to be honest. I don't think they are particularly interesting. The interesting comes from this one, from the actual energy exchanger, because what this allows, and this is the core feature of this is not energy production. This is energy transport. So it doesn't produce any power, but it takes power from a location where you have excess power to another location where you have insufficient power. And where do you have excess power? You have that in your systems with a Dyson Sphere. There we go. With a Dyson Sphere that says subscribe. So that is my subliminal messaging for you. So I don't have to say it. There we go. Didn't say it at all. And so in this system, we will have way too much. You can see we have 30 gigawatts of power, which is absolutely insane. So if I could take that power and transport it somewhere else, then it would be super nice. So that's actually what it does. It takes power. And the brilliant thing about this is that unlike any other power supply in the game, this doesn't take any resources. Yeah, but no, it doesn't. All right, shut up. It doesn't take any resources. The way it works is you are taking the same accumulator, you're charging it, you're moving it somewhere else, you're discharging it, and then you bring it back to charge. So in that process, you don't lose any materials. And then I can hear the typing in the comments. I can hear it. But what about the warpers? Yes. But warpers are cheap, dirt cheap, so don't care about them. Don't care about warpers. You will use a few warpers. You can transport 1,000 of these accumulators in a vessel, at the late game when you have that. And if you are transporting 1000, you are transporting 135 gigajoules of energy, which is enough to send out 70 logistic vessels. So I wouldn't really consider that to be any kind of a resource. The point is that if you're using anything else like fusion or antimatter or anything like that, it is you will use materials, and you need to have a big production facility to set that up. Now, I don't really want this to be a competition between the suns here we have in the very late game, but because that is exactly that. That's the very late game. The accumulators is something you have very early. As soon as you get your first Dyson swarm up, you actually can start transferring energy between planets and systems, and that's basically where you want to go. I also am of the firm belief that you can make do entirely with these if you want to, and I think I want to do that in maybe an upcoming series. One thing to note is that they are quite big, so when you start placing them, for example, like this, close to the holes, you can't make them very close. They should be able to work sort of on the big grid, but you can see in this case, yes, they can work on the big grid, but here, and that's just so something to keep in mind. They take a lot of space, but they generate 45 megawatts of power. That's the same as, let's see, isn't that the same as, yeah, 5 mini fusion power station. That's pretty good. All right, so that's some of the basic functionality. There are some things that there are some shortcomings or some deliberate implementation or undeliberate implementation that you need to consider. So the thing is, you can see here, they will discharge, because this is how I power the planet, partially at least, they will discharge at a rate that will match the consumption. This is where one of the, I would say, oversights in the implementation comes in. This is a setup, especially in this way, so you can see it. What this will do is, you can see it's not discharging at the maximum rate of 45 megawatts per megawatt. That's 45 megajoules per second. That's also one thing that I just mentioned, is that since this discharge takes 3 seconds, that means each accumulator has 135 megajoules of power. That's something, right? So we have this, and why is it discharging at 19 megawatt? And the reason is, it is taking 6 times the 19, and that is matching exactly the consumption, which is now means that you can see the consumption here, the yellow part, is matched by the discharge here. The problem is, these should be 0. You really shouldn't be discharging anything when you have solar energy working. These ones are also producing power, so these are they're not being used at all. You can see they can produce 12.5, but they're only loaded 27%. So the problem here is, and that there is no priority set between the different types of resource. So this means that the exchanges will scale down to match the consumption, but they will not scale down to if there's something else that also produces power. So in the way I would look at it is that ray receivers, solar power, wind energy should always be the first priority, because it doesn't take any resources. So that should always do first. If this is enough power, everything else shuts down. That's how it works for fuel-based power. And if that's not enough power, the free power, then exchanges should scale up. And if that's not enough, then the last one should be all the fuel-based power. That's how I think it should be implemented. Unfortunately, it's not implemented at the time of recording, so we have to do some tricks, which is one of the next things I want to do. But it's very important that you are aware of this. That means in this case, you're sitting here and consuming accumulators, full accumulators, even though you're actually, damn it, that escape thing, even though you have enough power from the ray receivers. So kind of something you have to be in mind, which means the very simple solution is always only use always only use energy exchanges if that's going to be your power solution. That's the easiest, but I'll show you a trick to how to get around that. One more thing that's important and is an advantage towards compared to the fuel-based power supply is that these are belt fed, so you can get a belt directly in. That means if for whatever reason I run out of accumulators in here, the whole thing will shut off. If I didn't have any other power, But as soon as I get something in, they will kickstart again. If you have fuel-based power, the inserters or the sorters will have stopped and they will not get back up. So in case you have some additional power or some fuel-based power, you will probably should have some kickstart power that is at least 10% of the demand. Otherwise, it just can't get out of can kickstart the network. So that's something that's really neat, is that it will automatically start because they are belt fed and not sorter fed. Really cool. The last basic thing I want to let you know about this one, it's super important, is that, and this is one of the other shortcomings, the reason why most people probably don't want to use it on a galactic scale, is that you must be able to get rid of the empty accumulators. If this fin fills up to 10,000, then it starts filling out the belt. If the belt fills up, this one fills up. It cannot be output anymore, so it cannot input. Power shuts down, nothing's working. So you must design a system that will prevent this from stockpiling, so you can always consume enough accumulators. Super important. And that's what we're going to be taking a look at now. So here we are in a new setup, and I'll allow you to sort of look at it in detail, and I'll explain what it does. This is to combat what I just explained. How do you manage your setup at a galactic scale? This is it. So at the very core of this design is the premise that you are only allowed to add more accumulators if there's not enough in the network. So you will always have to prioritize the ones coming returned from all of your planets and outposts. Those must always be prioritized for charging, and only if we don't have enough of those, then you are allowed to add more to the network. So we are going to set this up the way. Another thing that you have to, I don't really think I've found a good way to do this. You must make the production at the same location as you do the charging. That means you find a planet that has enough power. This one has a lot of power. At least now I've just hooked it up for 2 gigawatts of power, so it can go crazy on the charging. What we're going to be doing is we are going to put some demand in here. There. Now we will start producing it, and you can see that it goes out here and side loads to these. So I will also go, hey, from anywhere in the world, give me all of your accumulators. All your empty accumulators. That means it sends it out. And what this does is, what we want to see here is that we have 2 big outposts here with 60 there. They need to be having chargers, and they need to have here warpers as well. Get some warpers in. This will be provided to the network. So I have 10,000 plus 10,000. What the steady state will be for this setup is when this one is full and this one's full, so I have 20,000 in my network, and this one is empty, there's no more being brought in, and it goes out on this belt up to here, and then this production here will fill up the belt up to that point, and at that point it'll simply stall because they can't input any more full into the network. And the only thing, okay, so now you can see here, now this production here will jam perfect. It'll jam as someone forgot something here. Whoops. Someone forgot something. Please don't mind. Here. There you go. Now that works. So what we're seeing now is that as long as things are coming in from the global network, now I say global, from the galactic network, they're being brought in here, then they will prevent any production of additional accumulators in the network. But when it happens as this, I don't have enough inbound. Well, they are inbound, but they're not here. Then this one will get started on working again, supplementing more back into the network, so that I will eventually have, let's see, let's put these in, because, well, why not? We can also put these in. Okay, here's another little trick for free. You can't put in because it'll try to do that, but if you go to map mode, you can put them in anyway. Ah, clever. Free tip for you. And you can see here, as long as something is coming in from the global network, then the production of additional accumulators will stall. What this means is you will then, when it's in a steady state, have 20,000 full accumulators. You can set it to less, but there's really no reason for it. It sounds like a lot, but just build it. Then add an outpost such as this one. This will be simulating just a random outpost somewhere in the world. It will do exactly like this. This is also how you can edit the Temple of Effectiveness to match with these. You will request, actually also need to be local supply, and yeah, so the funny thing is, because it's on the same planet, it actually behaves weird, because I can't take these out. I'll just set up. Yeah, so you will request 1000 in, and this one will be out here. I have to make sure that we can consume this, even if it's on the same planet. Let's see where. There we go. So this one will also just, in this exceptional case, it will actually also take the local ones. So what you're seeing here is these are charging. You can see they will charge at the maximum rate as long as there's enough power. And that is, you can see how much power we're consuming here are charging. And ideally you would want to have this on a planet with lots and lots of ray receivers, so that you're for free taking the power of the sun, putting into batteries, shipping the batteries out into the network here, and then bringing back. And then we'll reach a steady state at some point where we have 20,000 full accumulators. We have nothing in here. And then when you hook up a new station, it will basically be in a position where it requests 1000 full accumulators, and then it'll probably sort of build up to 1000 empty accumulators. When it reaches 1000, it'll immediately be picked up and brought back to this location. So it'll be in transit. And when you then hook up another new, when you hook up, and it'll basically be in a steady state where there's 20,000 here, and then 2, maybe 3,000 sort of circulating for each planet. And when you hook up a new planet, it will start drawing from this location, but if there's nothing coming in on this one, then it will start supplying it, it'll start building it and supplementing the network. So you can see here, right now we have quite a bit, and that's perfectly fine. It will just decrease, run down, and then be filled up here, and then we'll reach a beautiful steady state system. So this one, I'll just let you see how this. You can also, this is just my way of doing it, but you can also just make it go over. It's basically the same thing, especially if you set up the filter correct. This just makes them pass through in different directions. I prefer that, but that's just my kink here. The important thing about this is you take the empty accumulators and feed in to a row. I have 10 on either side, so this is 450 times 2. That's 900. That's 1.8 gigawatts of power I can consume and convert. That means I can provide 1.8 gigawatts of power to somewhere else. Pretty nice. And you can feed a lot, since they take 3 seconds to do one, so you can actually feed 90 of these to one full belt. So you can, don't worry about it. You can get enough. You can still scale it up quite a bit more than this. But this was prove the point. The point is, empty accumulators in. The produced accumulators must be side-loaded. I would prefer side-load to a priority splitter. I think side-loading works better. It's also very visible in this case, that it doesn't go anywhere, so it just gets stuck there. So you can see this is the situation. It's stuck. This will be the situation that we have in, I don't know, 99% of the time. I can't do that. And until this one goes down, and then it will fill up. So that's basically it. You have the inputs, and they go back again here. This one is simply just 3 inbounds, and then I'm outputting on both sides. That'll sort of work as a balancer. It's the easiest, cleanest way to do it. And that's basically the way that you will set up the charging and then managing it on a galactic scale. And yes, it works. There you go. I'm sure that someone will comment like hypothetical edge case scenarios about when you have very many planets and they all, for some reason, send out things at the same time. And the answer is, it's fine. It's just gonna be a while, and then it'll settle back into the only thing that could potentially be if you are suddenly stopping the production at all planets and for many hours. I don't know. What we're going to do now is I am going to fly back to another location where I have the last bit of the setup on how to prioritize, self-balance the use of accumulator of the exchangers and it's actually not at all this one. It's Kappa Sagittari, that one. We're not going to fly there, but I will just jump out there while I explain the next part. So, this is the part in my tutorials where I say thank you to my sponsor. My sponsor is always you guys. It is the beautiful people who choose to support my channel on Patreon. So if anyone feels that what I do here is valuable and want to chip in and help make this keep going, then Patreon is an excellent way to do that. So thank you very much for everyone who is supporting on Patreon. I really appreciate it, and I couldn't keep doing what I do here without you. So thank you very much. So we are now back here at another location. This is a location that takes quite a lot of power, and we have built a discharging station. So we're bringing things in from the network and we're discharging, and now we have the big problem that I've highlighted before, the fact that I have my generation out here that comes from solar energy that you will see this solar belt all around the world. So that gives about 300 megawatts of power generating. But we are consuming 500 megawatts of power. So what does the exchangers by default do? They completely ignore the generated power, and they go up and match exactly the consumption. You can see this blue bar here is equal to the orange bar. So the discharge is now equal to the consumption. It really shouldn't. The blue bar should only be up to the part where it's supplementing, it's doing whatever is needed, not all of it. So that's the problem. So how are we going to do this? Well, there is a really cool trick. If I start discharging, if I start charging, it will use all the power it can to charge. It'll use all excess power it has to charge. But if I discharge, it will discharge at a faster rate. So I have built over here parallel. This is 900 megawatts of power being discharged, and if I fire this one up, taking all the empty ones in, then what happens is these ones will start charging at a reckless pace until they use all excess power for charging. These ones will start over consuming. They will consume as much as they can, or they will discharge as much as they can. So basically taking a lot of power here, and we are now discharging it. These are now discharging as fast as possible because there is a demand for it, and these are now recharging as fast as they have power for it, which now means that all of my power out here is being consumed. All of my discharge is being consumed, but some of the discharge is used to recharge. It's silly, but you can also see here, if we compare this is discharging at 45, this one is charging at 29, so it's actually only consuming the excess, which is 16 megawatts for each, which corresponds to the amount of power that was needed to go from the 300-ish that was consumed, or that was generated by the solar, up to the about 500 that was being consumed by the entire factory. The one thing that you have to be wary of here is that in this case, the setup has to be such that the ones coming out from here go in to a priority. Here, they are prioritized to get in here, which means that you're only bringing in additional accumulators from the network up to the point where they are being needed to, in addition to the stuff that you are recharging. So what I've done now here is basically by setting up a big build. This is unfortunately how it is with the implementation, but the fact of the matter is that it works. It works so that now you can have mixed power on a planet, and you can use the exchanges to only supplement with additional power. I think that's pretty cool, and that is a really cool way that you can now make exchanges work really well. So the biggest two disadvantages I see about exchanges, well, maybe there are three, but the main two are: how do you manage it on a galactic scale so that it doesn't jam? Well, we did solve that by only producing empty accumulators when there is room for it in the network. And the second one is exchanges always take priority, and I can show you, well, it does take a bit of power, a bit of space, and a bit of infrastructure, but here we've done it so that it actually works really well with other power sources, so that it is only the supplemental power. It's basically a secondary power source instead of a primary power source. The third argument is artificial suns are better. Yeah, but they're also very late game, and you may not have them. And even if you have them, it's going to take a lot of production line to keep it fed. And and until then, this is also a super efficient way of working, and it doesn't take any uses. As long as you don't add more planets, it's the same accumulators that gets charged, moved around, discharged, moved back, charged, and that's a. So all of this is just a infrastructure investment you do once, and then you have your 20,000 or 30,000 accumulators in the network, and they will just keep flowing. So I hope that this tutorial has shed some light on the awesomeness that is energy exchanges. I really, really love the implementation. I really love the idea of it. The implementation has a few things that are interesting, but it also allows someone like me to come up with clever solutions for how to solve those problems. So I hope you have enjoyed it. I hope you can now see how you can use exchanges either in a small scale or in a big scale in your galactic spanning empire. Thank you very much for watching. I hope you enjoyed it. If you have ideas for future episodes of tutorials, then by all means let me know. It is at a point, my Let's Play is at a point where the frame rate is so low that I'd rather focus on tutorials than the Let's Play. I will still continue more on the Let's Play, but I have to dial it back because my PC is burning hot from playing it, and the frame rates just can't keep up. So thank you very much for watching. I hope you enjoyed it. I will see you guys in another Let's Play or tutorial, either Dyson Sphere Program or some other game. Thank you very much. See you next time. Until then, take care and stay effective.